Good evening.
Good evening. Hello. Now I think I can change the background. Give me a second. We will start shortly. Okay. So today's topic is how to build a auto-scaling group. Autoscale, by autoscale in cloud, we mean that we will increase the capacity of a machine of a website or an application if the load increases. So for that, what we need to do is, first of all, the term here is load. So we will first configure the load balancer to balance the load, and after that, when that load balancer is working, then what we will do is we will attach a auto scaling group to it to see that how it grows when the load increases. And after that, we will attach growth policies to it, so that whenever we put actual load on it, to see how it increases, as well as when the load is taken over, it decreases. So actually, the main function of cloud, the main beauty of cloud lies in this functionality, that we can increase or decrease the computers which are processing the data according to the load they are handling. We don't overestimate, or we don't build our data centers just to accommodate the maximum load and pay for them most of the day when it is not there. So let's start. I will share my screen. So let me start. Please let me know if the screen is visible.
Yes, visible.
Okay, thank you. So we will start with the very first thing, that is we will start with the EC2 machine itself. So here, if we see, we have a very clean slate. So let me know if the screen is visible. Wow, sorry. Give me a second.
Yes.
Somehow my YouTube got started. So here if you see, there is nothing. So I will go furthermore because I was just working with the load balancers and everything. So I will delete everything which is not part of this exercise. So here I will go ahead and delete whatever I had, these security groups. So let me first just illustrate what a security group is. Security group is the permissions of a EC2 machine which which is applied to the EC2 systems, as well as the permission of all other resources, the permission grouping of all other resources which are there on the Amazon EC2 or AWS network, or the virtual private network of AWS, which we are right now we are seeing. So here, if you see that there is a default security group, so there are certain permissions, but we will create our own security groups over here and give permissions to them to connect to the EC2 instances as well as connect to the load balancer. So first step, before creating any EC2 machine, whoever has joined, can you please be on mute? So first we will create a security group, and then we will go ahead with creating the machines. So again, before I create the security groups, I must tell you one thing, that we will be here deploying an application, which is pre-built application. It's a web server which can be accessed through internet. From any public domain, it can be accessed. And we will run that application web server on our EC2 machines. So first, we will start building our EC2 machines with the security group, which we will create right now. The security group will allow permission from my system, which is depicted by my IP here, to modify it. Like we can SSH to the EC2 system, or we can log into the application to the EC2 system by using only my IP. There will be no other systems which can communicate with the EC2 machines which I will build. So from the internet, anyone except me will not be able to see directly whatever machines are there, but everybody will be able to access the machine through the load balancers. So that is the fundamental. So whatever we do, we will do the load balancer from public domain. From public domain, the machines will not be visible. So let us start. Let me start first creating the instance security group for my EC2 systems. The name just it is SHA instance. I will give the name instance over here. Now inbound rules. This is what I was talking about. What I can do is, from machine I can do SSH. From where? From my IP. If you see, it is only from my IP I can do the SSH. Another rule I am going to add: to access that application, I will expose port 4567. So 4567 will be used to access that application. Also, I am limiting that 4567 access to my IP. So this will be my security group. Again, I am reiterating, only SSH and TCP from my IP will be allowed on this security group. This is the fundamental thing of any web server deployment, that only admins can access that. Otherwise, you will be accessing it through some other interface. So we have now no instances. We have security groups. So let us create instances. For that, what we will need to do is we need to create launch instances over here. Click here. We will select the very first one, which is available for free for the demo purpose. It is T2 micro of 1 virtual CPU and 1 gigs of RAM. Please remember this, this configuration, 1 CPU and 1 GB of RAM, because we will be using this T2 micro throughout our demo. Now the instance details, we have nothing to do over here. Just go on clicking. We will add the default storage of 8 GB, which is required to install the operating system. There will be no tags. Here comes the next option, comes for a security group. So here we will select the security group which we created for the instance. Go ahead. We will just review 1, that's fine. 2 security groups, that's fine. We will create launch. Whenever we launch an instance, we need to create a key pair. For demonstration purpose, I have already created a public private key pair, which is already there. It is there as app server. So I will select this existing key pair and I will go ahead and launch. So everything is done. Now the instance should be launching. If you see, it is on the pending state. So we will refresh for some amount of time. So we can see that public IP has been given. So the instance is right now ready. Yes, it is now running. So we will then load the necessary software package for which we need to install everything to the instance. So first we will use Putty. In Putty, we have already configured the prerequisites, that is the public private key pair. So see, this is an advanced level of AWS EC2. So I assume that everybody is accustomed with the public private key pair and those type of concepts, because it is out of scope for me to discuss it over here. If you require, then obviously I can make a video and post for you. So let us right now take the public IP address over here. I copy it and I paste it on the IP address that was there on the system. So my Putty now points to EC2 user @ this public IP address, and the configuration name is application server. I click on open. Now there will be a some time delay because I am accessing a machine on the internet. So let's wait for a few seconds. I think there is some problem. So let me launch the Putty again. We'll load the app server here, and then we copy the IP. Is copied. We'll load the configuration and click open. Yes, now it is already there. So you can see that we have already logged on to the system. So now I will load the application. So for that, I would need a custom script which is already stored in my system. Okay, let me walk you through the script. First, this script is doing the update of the update of the operating system, if any. Then it installs a Java JDK. Then it configures the Java and Java C. After that, it gets the application from GitHub. Then we create over here the script to execute it on startup. After that, we enable that script on startup. So we will be going through the steps over here. I will just selecting one command after another to load to execute it on the system. So my students who have logged in already know this about this script. So now we will be installing Java. So we can see one by one it is installing. So it is done right now. Now what I will do is I will get the application from the GitHub. Okay, it is for downloading anything from GitHub. What we need to do is we need to just use wget and the URL name. Now we will create the script for loading that program in the startup. Now we will just enable that service which we configured. Here we have enabled the service. Now we start that service. So here the service, sorry. So the service has been started. Let us examine. Because it is from my PC, I can use, just go log into the IP address and see if it is running. Just do one thing, Control C the application. Here, Control V the IP address. Obviously, we need to put somehow it is not accessible. Not a problem. What we will do is we will just go ahead and check it over here. So now what we will do is we will create an image. We will create the image of that instance which we have just built. So first click on the instance ID, and then we can click on the image and template. So we will go ahead and create an image. That is, I would say, so this is called creating an AMI. we will create our autoscaling group based on this AMI only. So now if we see here, the image writing is going on. It will take some time. So let us resume the meeting after 5 seconds. Sorry, after a minute or two. Okay, so here is the instance. Forgot to give the port name over here. So it is a single instance running running on a bare bone PC. So let's see if the AMI has been created or not. It's still working on it. So here one concept is just to clarify. One concept is needed. What is an AMI? AMI is the machine image, the image of the application we built. Because in a production environment, what happens is every time we deploy a server, we need to deploy it based on a application image. So that process is a cumbersome process, but in AWS it is just as the image. Whenever you deploy an application or an upgrade an application, you can keep an image of that application, and then what you need to do is you need just to spin up a machine. So that's what we are going to do right now. Over here, we can see that we have spun up a machine. Our image is ready. So from this image now, we will create another EC2 machine. So we will go ahead and create, click on launch. So again, the instance is T2 micro. Instance details is like this, same. The SSD, the storage is same. The security group will be the existing one, that is the SHA instance. Then we can just go ahead and see launch. So we will select a existing key pair. So we will just launch the instance. Then we go ahead and see that we will go ahead and see that this is the public IP is there already. Just we will wait for this instance to get okay. So this is running right now. So let us now log into this instance to see what it is showing. Formula is very simple. Just we use this one. Instead of that, we will just change the IP address and the port, that is 4567, we will give over here and see it is running. So both the instances are running now. So we are good at the instance level. Now we will see the functionality of a load balancer. Okay, so we have created two instances. We have created an image file. Now we will go ahead and create a load balancer to access these instances. So again, for creating a new thing, obviously we will need to create the security group for it. So we will just go ahead first and and go ahead and create a security group for load balancer. So here I give the name. Here I give the load balancer. The inbound rule. Yes, the load balancer will be accessible to public. So here what I will do is I will give a inbound rule of HTTP to public, that is anywhere. So the load balancer can access connections from anywhere and forward it to our application. So we just have the load balancer which accepts connections from anywhere. If you see here, it is only HTTP port will be enabled. We need to remember this HTTP. But we will also do another thing. We will let the security group of the instance to accept this load balancer, because otherwise we will not be able to connect to the systems which this load balancer is working, for which this load balancer is configured. So here on the instance part, we go ahead over here. We just edit the rules. We add a rule of custom TCP from 4567. Here we select the load balancer, that is SHA load balancer over here. So what it is now, what the instances will do, instances will allow me to connect to them from SSH, from the 4567, as well as it will allow me to connect, it will allow everybody to connect through the load balancer. Now what I will do, when I saw that those instances are working in working state, so I don't need access right now. So I go ahead and delete my access. So all we will do is we will access through load balancer. Let us see. So I have edited the instances security group and have only the load balancer access it. So if I go directly right now, say if I give the IP address right now, still it is allowing, but let us wait for some time. Okay. Okay, we will check this after some time, after the changes take effect. Right now it is allowing me to access it. Just let me see, go to the instance and see. Okay, inbound rule states that it can access through only the load balancer, but still I think the credentials are cached. So first, let us go ahead and prepare the load balancer. Then we will check this thing. So for load balancer, we need to create a target group. A target group, by target group, what I mean? By target group, I mean that the systems which will be connecting to this load balancer. So first, let us go ahead and create the target group. Okay, we will here the first choices of instances. Yes, we will have instances. Target group name, let me give it. Target group is SSH target group. I gave the name. The protocol is port is 4567 as earlier. The VPC is over here, and the protocol version is HTTP1. Health check. Okay. For health check, what we need to do is we in our application we have. So if I see over here, we have a function called health. So if I go, it shows healthy. So this function we will call. So we will give it /health. And advanced health check settings would be here. The interval normally what we give is 10 seconds. We can modify the success codes, we can configure, but here it is not needed. We will go to next. Okay, so we have two instances. We will select this and include them in our target group list. Now this target group is created. Now this target group, let us see what it contains. It contains two instances. The target group, because it is still not attached to a load balancer, so it is not giving here the instances are not used, but we see that this we have two instances over here attached. The health parameters, the attributes here it is 300 seconds for deregistration. What is deregistration? Deregistration means that in case an instance is unhealthy, it will wait for 300 seconds to drain it or disassociate with it. So here we will change it to 60 seconds. So here I have changed it to 60 seconds. Now we will go ahead and create the load balancer. So our load balancer will be of application types. So we will go ahead and create application load balancer over here. The name is SHA load balancer, internet facing. The listeners is the HTTP from port 80. Availability zones, we are selecting every availability zone we have. Then we will have the security settings. So we don't have a HTTPS right now, so we will not do over here. Now we need to assign a security group, so we will assign this one, the load balancer security group we have created. Now the target group, we have already a target group, which is SHA target group. There is a listener which is already configured. The health parameters are already configured. Everything is there. So now we will just go ahead and create the listener, create the load balancer. So everything is set up. Here we can see that the intervals we set is set. So we go ahead and create it. Close. So this load balancer is now provisioning. It will take 1 or 2 minutes. Yes. So here we can see that this load balancer, if we ping this load balancer, if we put the load balancer's DNS over here, we can see that it is just calling that application on 4567 port. Here you can see the IP address is changing. So this load balancer is now working. It is just distributing the load between two applications, between two servers which are registered under it. Okay, now let us verify again if the servers that should not connect from this machine. So we take the IP address of one server and put over here the individual server. We should not be able to access that. So if you can see, this one is still going on cycles. After some time, it will just, show an error. So I am just waiting for the error screen to show that I am not able to access the individual application right now directly. Okay, so this is it. We can see that we cannot access the application directly, but if we go to the load balancer, click its DNS, paste it over here. So here the applications are working. So now let me show you another funny thing about this one. Say here is an instance. I go ahead over here. Say I select this instance and go ahead and terminate it. Now, if I am now terminating the instance, let it get terminated. So it is now it is, I think it is terminated. So let us check the load balancer once again. So now if you see, there is only one IP. So if one instance is not available, it will just go ahead and send it to another the instance which is available. So the load balancer, it is working fine. So now here is the functionality of a load balancer. Now what we will do, we will terminate all the instances and we will go for auto scaling groups. So before going into auto scaling groups, what I need to tell you that auto scaling groups, before preparing an auto scaling group, we need to have the application server image ready, which we have already over here. So my auto scaling group, what it will do, there will be no instances, there will be no active instances. My auto scaling group will spin up all the required instance. Okay, it will maintain the health of instance. Once the load increases, we will increase the load by putting application stress on the servers. We will increase the load, and after that, once the load increases, it will increase the application, increase the servers, number of servers, and once the load decreases, it will decrease the server. And if I terminate, just as what I have told, that whenever we are building a load auto scaling group, it spins up the instances by itself. So when the auto scaling group is terminated, what will happen, that it will kill all the instances that it had launched. So that is the thing. So first let us go and kill all the instances which are there, so that we can start on a very clean slate. So I have instructed the thing to terminate it. So while it is terminated, let us go into auto scaling group right now. Please remember that the basics need to be very clear before we enter into this advanced domain, because this is the crux for our next course, that is the Amazon EKS or the Kubernetes clusters. So what our objective over here is to gain enough confidence so that when we are delving deep into this, the intricacies of the Kubernetes clusters, we can be sure what we are doing. So here, first, when we just go, see, there is a launch configuration which was from earlier class. So I am just deleting this. Okay. Now, first we will create a launch configuration based on the template we have created earlier. So what we have in our plate right now, we have the necessary security groups, we have a tested instance, we have a tested load balancer, and now we are going to create the auto scaling group. So first, let us create the launch configuration. We give it a name, say SHALAUNCH AMI. AMI is what? That is the Amazon machine image, the application server image we built earlier. So I just select it over here. Now instance type. So when we were creating the previous, in the previous hour, when we were creating the instances, I told that to remember what instance we built. So we built a T2 micro instance with 1 CPU and 1 gigs of RAM. We will just select this one, click on choose. So this is our instance type. The image we have selected, we have named the launch configuration, and nothing else is right now needed. We will select the security group. Please remember this is a launch configuration of the EC2 instances we will monitor by this auto scaling group. So the instance security group will be assigned over here, because this launch configuration will be used to create instances. So we will just put the instance security group over here, and then we will choose an existing key pair which was already there, the application server, and create launch configuration. So we have the launch configuration ready. Okay, so here it is there. So everything is there. Now what we will do is we will create our auto scaling group based on this launch configuration. We click on autoscaling group. We give it a one. There are two things. One is launch configuration, one is launch template. We will have a separate video on launch template. Right now we will be going to use launch configuration. So we selected this launch configuration over here and clicked over next. The VPC will be same, that is the virtual private cloud. We will select three machines, three zones, three regions within the availability zone, because we need to create a fail-safe system, so that if one region goes down, another region picks up. So we click three regions, then we go to attach existing load balancer, because we have created already, and then we have choose from your load balancer target group. So we have a target group configured. We select it over here. The health check type. So we have provided the health check type, health check on the load balancer itself. So we will click it. The grace period, this one we need to shorten, because what happens is that we will exceed the time of our meeting and nothing is needed. So the desired capacity would be 1, minimum capacity would be 1, and maximum capacity would be, okay, let us make it 1. Let us make the desired capacity 3, minimum capacity to 1, and maximum capacity to 6. Let us see what happens. Click on next, next, next. So we review everything. Okay, the desired capacity is, here we can see that the desired capacity is 3. So this is the auto scaling group. We have no EC2 instances right now. Here we can see there is no EC2 instances, but what you see is 2 instances are on pending state. So what are these 2 instances? Because we have terminated, right? So now there are 2 new instances which has come up, which is created by this auto scaling group. If we come and see over here, click on the auto scaling group, click on the activity, we can see that it is trying to create instances, say 2 successful. Okay, it will be some time before it create another one. So if we go to the instances, now we can see that it has created, it is creating, see this one is also pending. Already 2 instances have been created, and one is, again, third one is also up. So now if I go to the load balancer and do F5, we will see first one, note the IP address, it is 1568, then 340, then 15, sorry. So it is now still 2. Yes, now it is 3. So we have 3 machines, as we have specified over here that we need 3 machines to run. We need 3 machines to run. So it has built 3 machines. Okay, it has built 3 machines. That is our desired capacity. And the funny thing is that if you go to these instances, you will see that these 3 instances, one is on South 1A, another is on South 1B, another is on again South 1A. Because if you go and see the activity, it should have been C, but in that region there must have been some resource crunch. That is why it has gone ahead and created in South 1A instead of South 1C. According to algorithm, there must have been 3 machines, but it has built 2 machines on the same group. See here. South 1C has failed. because of South 1C have failed, it has created two machines on South 1A itself. South 1C might not have the T2 micro instance over there. So that's why they have not created, it has not created the instance on South 1C. It has gone ahead and created on South 1A. So we have three as desired. So now what I will do is, just for simplicity's sake and for time's sake, I will just change this capacity to 1 and maximum to, here I will do it as 1 and give maximum to 3. So here now I have given the desired capacity is to 1. So now I have changed, as I have changed the required capacity to 1, the systems which have been spun up, that should go down right now. So let us see the activity. It has not yet started. Actually, it takes some time before we go ahead and see that result. So just let us do something else and let it do its job. So first thing has been proved. The theory of load balancing has been proved. The theory of auto scaling up to scaling up to the required instance, that has been proved. Now the third one, increasing load on the instance. So what we will do is we will increase the CPU load of an instance through a Google tool we have, stress testing. We will do the stress testing of an instance. So now let us see the auto scaling group over here. Yeah. So here we will go and click on automatic scaling. Here we need to add policies. We need to add policies so that if, say, for the CPU utilization goes beyond, goes above 60%, it will increase the number of CPUs and number of machines, so that my CPUs doesn't hang. And when the load is beyond, say, 30%, it will decrease. So let us create those two policies. So over here, we will just go to simple scaling. The scaling policies are called scale up and scale down. Scale out, it is for increasing the capacity, and scaling means it is decreasing the capacity. So the first policy would be SHA scale out. Okay. Now what we need to do is we need to add an alarm. So this alarm should have been, we need to CloudWatch is a free monitoring tool available for monitoring your instance health. So on that CloudWatch platform, we will build the alarms. So first let us go to CloudWatch. Yes. Here we need to select a metric. So for metric, we will just select the EC2 instance, and there we will select the auto scaling group, and there the auto scaling group name should come here on this one, auto scaling group name. So it is SHA Autoscale 01. That was our auto scaling group. There CPU utilization will be our metric. So we select this metric. So AWS EC2 CPU utilization auto scaling group is this. Statistics is average CPU utilization. Period is 1 minute. And for 1 minute, if my CPU utilization is greater than 60%, then we will add something. So that is the alarm. We don't trigger anything over here. So we just remove all the triggers. We will trigger on the auto scaling group itself. We can also trigger it over here. We'll just name it SHA alarm scale out. So sorry, the spelling. Again, SHA. So we have created this alarm. Now we create this alarm. Okay. Now again, we will create another one for scale in. We will select the same metric, that is EC2 auto scaling group. Select the CPU utilization. Select the CPU utilization over here. Select this metric. Statistics average period, again we just put it to 1 minute. Static, lower than or equal to, we put here 30%. Additional configuration, nothing. So we put here 30%. So in case a CPU utilization goes beyond this, we will just scale down. So for that, we remove all the triggers over here. We will put nothing. That is SHA scale alarm. So we have created, sorry, the names. Okay. Here. Okay, let it be like this. SHA scale. So we have two alarms. One is SHA alarm scale out and one is SHA alarm scale in. SHA scale in. So first we will select the alarm, that is SHA alarm scale out. If it increases, we add 1 capacity units and then wait 60 seconds. Create. We will create another policy. Here, simple scaling, again, SHA. Do a refresh. Select a scaling. We will remove 1 capacity unit within 60 seconds. Create. So we have created the scale in and scale out policies. Now we will see, let us check with our instances, what is their status. So here we are seeing that all the instances have been terminated, only one instance is running. Why? Because what we did was, we changed the desired capacity. We changed the desired capacity to 1. So here our number of instances active is right now 1, according to our program, that we have changed the desired capacity to 1. Now what we will do is, we will do a stress testing. For that, first we need our load balancer to check the load balancer, and we will use the load balancer to determine if we need more machines or not. So this load balancer will tell us if the CPU utilization is going beyond its limits. So here the load balancer DNS, let us see. We have we have copied the DNS, and let's check. It should now only reflect 1. So here if we see, it is showing only 1, that is 33,250. Only that instance is running. If we go to the EC2 instances, yes, this where is the private IP? So let's check the private IP. Yes, see 33,250 the private IP, and in the load balancer, when we are running the application, it is showing 33,250. So this is the 33,250 is our present server. Now here is I have used a tool from Google, which is RESTful Stress. So I will use this stress testing tool to put stress on my system. So first, I will configure this stress testing tool. Here I put iterations. Go to settings. We select massive. Then we put iterations over here. Is say 10,000 and put our DNS name over here. So here I have put the DNS. Now I will just copy and paste the DNS in the tool itself. So here I have selected 5 times hammering to the load balancer, and then I give it a name, say stress test. And using this button, I can start a test. So let me start. Yes, it has started. See here, we can see that it has started. So we will wait till iteration 20, because that's where the performance takes peak. So we will just see here it is right now it is just warming up. It is just warming up the CPU. So over here, if we come in the console, we can still see there is single instance running. And if we go to this instance, we go to the monitoring, and then yes, here we just select custom, because 1 hour, 2 hour, we will not have anything. Just select it 15 minutes and let's see. So here the CPU stress is, if you see, it is just going down. So let us see when the stress actually builds up on the stress testing algorithm. See here the curve is going down. It is actually warming up. So first stress has gone over here. Say it says stress 1. So this iteration is now 7. So it will go up to 21. Let us see over here on the graph, on the CPU usage graph. Here we can see it is still not reflecting. Just refresh it for a minute. See. Still on level. Here the actual stress has started. So if we come again over here, see, this is the graph which is now talking its own story. So we can see that CPU utilization over here is going up. It is going up to 40%. So on the stress test tool, we again come here and see testing is going on. We are on 11. This iteration is at 11. You can see the graph is rising. All the graphs are actually rising right now. Here we can see, here we can see the graph is rising. The tendency of this graph will begin to climb. This graph will climb. See, it is climbing very slow, but it will start climbing. When it will start climbing, the game begins. Here you can see it is 15.631, and here it is 15 point. Here we get 15.521. So it is like that, 521 to 631. Still it is rising. We can go and see in the instances. It takes some time to build up the stress, but after that it skyrockets. So right now, if we go to our auto scaling group, nothing has changed. We go to our launch configuration. Obviously, launch configuration doesn't have any clue what is going on. So auto scaling group is still at 1.1. This should change. So let us come over here and keep a watch on the activities. So here, this one is at 10:49:06. We are at 11:04, and it is still at that time when it was terminating the instances, when we brought it down from 3 to 1. So we go to the console again in the instances, and we go to this instance, we go to monitoring. CPU utilization, we select 15 minutes. So it is still going up, it is climbing up. It has completed 22 iterations. So I think the time is up now for this graph to go up suddenly. Okay, I think it is about time. The graph is climbing. If we can see, it is still on stress 22, but it is not stress 28. So let's see. Still nothing. In instances, no changes. See, the desired capacity has gone up. The desired capacity has gone up by 1. It is on 2 right now. And if you can see, if you see, here is an instance which is spinning up. And if we go to the auto scaling groups, so if we go to the activity, here on the activity tab, we see that launching a new EC2 instance. Because if you see the reading, that the desired capacity, here it is telling a monitor alarm SHA alarm scale out instead alarm triggered policy SHA scale out, changing the desired capacity from 1 to 2. So it is spinning up another instance. So if I go over here and click on the load balancer, which was showing only one IP, right now you can see that it is showing 2 IPs. And in the instances, if we go and see the monitoring status here on the CPU utilization, you can see it has skyrocketed. Just let us give. So it's just like this. It has shot up. It has shot up. Now, if I go to the stress, the testing, here is the spike. Here is the spike. So when the stress increased, it rose up over here. Then we added a CPU, it again leveled. Okay, so let us wait for another 10 iterations to see that the CPU count max out. Then we will stop this test so that the instances can scale down. So let us come to the auto scaling group. So it is still at 2. And if I go to the activity, it has successfully launched an instance. So let us go to our monitoring screen right now, and we will wait for the spike again. So this was 20. This was 20, and this is 15.810. Just wait for a few minutes. Let us check our newest instance, which has gone up. So let me check. Okay, it is on 2307. So this one is the newest instance. Let us monitor this one. We were monitoring the old one. So now it is time to monitor the new one because load has been shifted to that one. Let's take a 15 minutes graph. So the graph is still not available. See here, it has started. It has started over here. So it has started at 48%. So I think we will be able to soon see a spike. It's going cool till now. Reduce it to 5. Let's see. So let us check the old one, how the status is. Old one is this one. We go over here, go to monitoring. Give it 15. So here you can see, see here it has risen up, then it came down. The utilization has been coming down, but it has gone not gone all the way down, because we are still stressing it, so it is not going down totally. It is just spiked down. So here, if I go to the stress screen again, it's still going on. We will wait for a few minutes. Here is the alarm screen. So everything is right now in proper shape. So there is nothing right now. As we see the stress test also. See, now you can see there is a spike coming up. Here is a spike. It suddenly spiked up to 16.023, but it came down to 15.085. So is 15.825. So these are early telltale signs. If you see over here also the graph has spiked. A graph has spiked over here. So there will be some spikes and the graph will just go on climbing up like this. So it's ups and downs, but it will now it is now trying to shoot up. So if we see the alarms right now, alarm has not yet been triggered. If we go to the EC2, that is the autoscaling group, the instances are still 2. We go to the instance monitoring screen over here. Normally, my observation is that here it is 64. It is the iteration number 73, which triggers the stress over here. So 64 means another 9 iterations we will be waiting for. Yes, 73 has passed. So it's about time. Still, it is very much beyond the limit. Okay, it seems that it would take very long. So let us see the scaling down activity. So we will stop the stress test right over here at this point. Just go for a very okay. So let me stop the test. It's already going to be midnight. So I have just stopped the test. So we have two instances running, and it should go down. Just register. It is still now it is 2, but it should go down. Okay, I think it has stopped totally. So now let us monitor it. So here we can see the graph coming down. I think it's time to the alarm to get activated. Okay, so here we can see the desired capacity has come down to 1. So it will just start now. Yes, it is just starting to terminate the instance. we come over and see, it will soon start terminating one instance. And if we go to the load balancer right now, you will see it is now only using one IP address. So the other one, it has stopped accepting IP address, and it will drain it, and then it will terminate. I have given it 2 minutes or 1 minute maximum. So it will start draining the instance after that. Here we can see now this instance is now shutting down, and ultimately it will get terminated. So now what happens is, if we just go ahead and select this auto scaling group and delete it. Okay, this is the last part of this presentation. So when we are deleting this one, what happens? Just go to the instances. We have seen that one instance was already getting terminated. Now we will see the story of the second one. When it is the auto scaling group, I am just deleting the auto scaling group. So when we created the auto scaling group, it just spun up one instance, right? It spins up the instances one by one. So it did that. Now when we are deleting it, what happens is these instances will start to get deleted. So one is terminated. The second one is now, I think, on drain part. So if I go to the load balancer right now, I will see that it has stopped working because it has started terminating the second instance also. So we will just wait that until this instance is getting terminated. So let us just wait for a few minutes. You can see the activity. So this is in progress, terminating the last instance. It is terminating now. Yes. So we can see that it is terminating the instances which it spun up while it got created. So that's it. Thank you. Thank you very much for attending this demonstration. Have a good night and stay safe.
Good night, sir.
Thank you.
Good night.
Good night.